Alright, we're going to start off with lesson 13, and this one is talking about the angle sum of a triangle. Okay, and I want to first talk to you about the angle sum theorem for triangles, and that states that the measures of the interior angles of a triangle is always 180 degrees. So we're going to write that down. Okay, so angle sum theorem, and I'm going to abbreviate it too. You can use abbreviations. Angle sum of triangles. For triangles. Okay, and all it says is the interior, which is the inside, angles of a triangle is always equal to 180 degrees. Okay? It doesn't matter what type of triangle it is. It could be a right triangle like this one. It could be an obtuse triangle like this one. Or it could be an acute triangle like this one. It doesn't matter what type of triangle. The interior angles 1, 2, and 3 equal 180. 4, 5, and 6 equal 180. 7, 8, and 9 equal 180. And in this case, because angle 8 is 90 degrees, that means that 7 and 9 have to equal 90 degrees together. Okay, so we want to prove that the angle sum of any triangle is 180 degrees. So to do that, we need to have some facts that we already know about geometry, and we're going to write those down at the bottom here. Okay, a straight angle which looks like it's just a line. Okay, so from here to here is 180 degrees in measure. That's the first one. The second one is what we talked about in lesson 12. Okay, corresponding angles of parallel lines are equal in measure. And the abbreviation for that is this: corresponding angles, okay, AB is parallel to CD. Now those could change, the letters of the lines could change, but it's corresponding angles of parallel lines. Okay, and then the last one, okay, something we already know, alternate interior angles of parallel lines are equal in measure. So we're going to abbreviate that: alternate angles of parallel lines. Okay, so these three things we're going to use. We've already proved them, and we're going to use them to work through Exploratory Challenge 1 and Exploratory Challenge 2. So let's move on to page 68. Okay, for Exploratory Challenge 1, it says, let triangle ABC be given. It's on the paper. Let a ray from B to C, on the ray from B to C, take point D, so that C is between them. So C is in the middle of B and D, that's what that's saying. Through point C, draw a segment parallel to AB. Okay, so this line AB is parallel to this line CE. Extend the segments AB and CE. Okay, so you would want to extend them using a straight edge. Okay, this is a straight edge. So when we extend them, it says line AC is a transversal that intersects the parallel lines. So here are parallel lines. Let me see if I can get that. These two lines are parallel, and there's your transversal if we extended it. Okay. So here it says name the 3 interior angles of a triangle. Okay, so we're looking here at this angle. So that's angle BAC, because we went this way. The next one is here, ACB, angle ACB, and the last one is over here, angle CBA or ABC. ABC makes a little bit more sense to me, so angle ABC. And then the straight angle would just be the line, okay? So that'd be right here, angle BCD, all the way across. What kind of angles are angle ABC and angle ECD? So ABC, right here, we're looking at this angle right here. And angle ECD, this angle right here. So when we turn them, they are in the same location on the top and bottom parallel lines. This is our transversal. Okay, let me make sure I'm doing this right. Okay, so here's our transversal. This is also a transversal, this line down here. So these two angles are corresponding angles. Okay, so angle ABC and angle ECD are corresponding angles. Of parallel lines. Oh, sorry guys. So because they are corresponding angles of parallel lines, that means that they are equal in measure. So angle ABC and angle ECD are equal in measure. What kind of angles are BAC and ECA? So BAC, which is right here, and ECD, which is right here. So these two angles. Okay. Okay, let me make sure I'm ECA. Sorry, not this one. ECA. This one. These two angles. Okay, so they are both on the inside of the parallel lines on opposite sides of the transversal. So they are alternate interior angles. So angle BAC and angle ECA are alternate interior angles of parallel lines. Because they are parallel lines, we know that they are equal in measures. So angle BAC and angle ECA are equal in measure. We know that angle BCD, which is the straight line, which is 180 degrees, equals the angle measure of BCA and ECA. So this one plus, let me do this. So this angle plus ECA, which is right here, plus ECD, which is right here, equal 180. Use substitution to show that the measures of the three interior angles of the triangle have the sum of 180. Okay. There are three angles because there are three angles in a triangle. We know that this angle and this angle are equal, and this angle and this angle are equal. So we're trying to find this one. Okay? So, to do substitution, okay, we're going to do three angles because there are three angles in the triangle. So, we know that the measure, I'm going to rewrite this out, of angle BCD equals the measure of angle BCA plus the measure of angle ECA plus the measure of angle ECD equals 180. So, because these equal 180, I'm going to substitute in the ones up here that equal the ones that are in my equation. Okay? So BCA I do not have it listed up here, so I'm going to leave that one there. Okay? So the measure of angle BCD equals, I'm not going to substitute anything in for that because that's the one that we haven't talked about, BCA, this one right. We haven't talked about BCA, this one right here. So I'm just going to leave that one there. So the measure of angle BCA plus. Now, we have talked about ECA. Right here, ECA and angle BAC, which is this one at the top, are equal. So I'm going to plug that in here. So I'm going to take, because these are the same, I'm going to take this one right here, the measure of angle BAC, plus. Now we've talked about angle ECD, which is right here. Okay, so we're going to plug in angle BAC here. Or sorry, ABC. And that equals 180 degrees. So all we did is take the original and plug in for the ones that were equal to it. So ECA was here and BAC were the same, so I just plugged in BAC. BAC is part of the triangle right here. Okay? And then I did the same for ECD. It's equal to ABC, which is also part of the triangle. So that's how we know that the three angles inside of the triangle equal to 180. Well, you can't see that. So the three angles inside of the triangle, okay, this one is equal to this one, and this angle is equal to this angle. So because they're a straight line, we know they equal 180. So this one plus this one plus this one is 180. And that's what we just proved here. Okay, so we're going to jump into exploratory challenge number 2. Okay, So here we go. The figure below shows parallel lines 1 and 2. Let M and N be a transversal that intersects line 1 at point B, at points B and C, so they intersect here. Okay, and they also intersect together at line 2 at F. Okay, that's just telling you what is in the diagram, so don't let that freak you out. It's just saying that A is on L1, B.
Any girls interested in girls basketball, there is a meeting going on now in the gym. That's any 7th or 8th grade girl interested in basketball. Please report to the gym at this time.
Okay, so it's just telling you where everything is located. A is to the left of B, D is to the right of C, G is to the left of F, and E is to the left or right of F. Name the triangle in the figure. So in the middle here, there is a triangle. Everybody see that? So when we name a triangle, you can't just write all the letters. You have to write the symbol for a triangle. So triangle B, C, F. I like to put them in alphabetical order. That's just me. Name a straight angle that will be useful in proving the sum of the measures of the interior angles of the triangle is 180 degrees. Okay, so angle GEF. And this is why I'm picking that. Because there are 3 angles in this triangle, we need one of them to be inside of the triangle, one of the angles. Okay, so I'm looking for a line that has 3 angles and one of them is inside of the triangle. So down here, okay, on number 2, we're going to say angle GFE, just straight across right there. Okay, and so our goal is to show that the sum of the measures of the interior angle of the triangle are equal to the straight angle. So one of the angles that make up the straight angle also has to make up the triangle. Okay, so that's why we picked this one. Okay, so now we're going to do what we did over here and find angles that are the same, like we did here, and then write this out. Okay, so I'm going to start with this angle. I don't know. Angle GFB right here. Okay. I know that it is the same measure as this one, angle CBF, because they are alternate interior angles. Okay. So, let me go back a step. I know that angle GFE equals GFB plus angle BFC plus angle CFE, which equals 180 degrees. That's what I'm going to start with. So now I'm going to find GFB, which is right here, and I know that it is alternate interior angles with CBF because they're parallel lines. So let me do this. Angle GFB and angle CBF are alternate interior angles of parallel lines and equal because of the parallel lines. Okay, so because GFB and CBF are equal, I can interchange this to be angle CBF. Okay, so then BFC is already in the triangle, so I don't need to find one that's equal to that, but I need to find one that's equal to CFE. Change colors. So here is CFE. The angle in the triangle that is equal to that would be BCF right here. Okay, and they are alternate interior angles. Okay, so they're equal because they're parallel lines. So angle BFC and angle, so not BFC, angle CFE, this one, and which is here, CFE, and angle BCF are alternate interior angles of parallel lines, which makes them equal. So that means that we can substitute in for this now. So I'm just going to start off, go back again, and write this out. So angle GFE equals, so GFB and CBF are equal, so I'm going to plug in angle CBF here. I'm just going to take this one out and plug this one in, plus BFC is not here, so I'm going to just leave that one there, angle BFC, plus CFE is right here, so I can substitute in angle BCF. And we know that all together, because they equal this line, they equal 180 degrees. Okay, so in the end, we should know that all triangles have interior angles who measure 180 degrees, and we can prove that the sum of the measures of the interior angles of a triangle equal 180 degrees by using a straight angle and what we know about alternate interior angles and corresponding angles of parallel lines.